Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at the electronic structure and periodic table. Now the periodic table is actually, you can see that they have been given in different sort of columns and rows. The columns are called groups and the rows are called actually periods. Now what we're going to look at, we're going to look at the electronic configuration, but I'm going to make it very simple for you to understand everything from the scratch. For example, if you see the periodic table, you will find some alphabets. And it can be like this: iron, sodium, hydrogen, chlorine, fluorine, and etc. When you look at these, you have some of them, they are represented by one capital letter, but some of them, they are represented by a capital letter followed by a small letter. Here people actually make mistakes sometimes. For example, if I ask them to look for carbon, they will go back to periodic table and they can easily find carbon. But when I'm going to tell them, okay, look for sodium chloride, sometimes they look for only nitrogen and C carbon, and they forget about A and L, and after that they actually gonna struggle to find small a and small l on the periodic table. So whenever you see a capital letter followed by a small letter, that's actually one complete element. So this is capital letter and small letter, so that is one separate element. It's not carbon. So you need to be very careful with that. One more thing I realized, a lot of people, when they have this sort of formula, they started looking at for NaCl in the periodic table. Periodic table will only give you one type of element in each box. So you will never find a formula of different elements joined together, or you will also not going to find like O2. Okay, you will only find the symbol of each type of element. Now, when you look at the periodic table, you will see the elements like this. It will have a big number and a small number, 6 and 12. Then you have nitrogen, you probably have sodium. These sort of numbers you will look in the periodic table. The top number, which is almost the double of the small number, is actually big number. It is called atomic mass. The small number is called atomic number. Here's the point, that the big number represents the mass of that element or that particular atom. So you have to remember that way, that the big number always represents the mass. Mass is something, how heavy is that particular object is. Now atomic mass is 23 of sodium. What does that mean in terms of chemistry? When you say atomic number, atomic mass, what does that mean? Atomic mass and atomic number means you have a number of protons plus number of neutrons. Same goes for this. When you have atomic number, that is a number of electrons or number of protons. So this is pretty difficult to understand. When we talk about the mass, we will look at the mass of proton and neutron inside the nucleus, because that actually predicts the mass of an atom. But when we look at atomic number, we will look at a small number that represents proton and neutron at the same time. So it will represent proton and neutron at the same time. So we can't say plus, you will say plus slash. So you can say sodium, if you write down proton, electron and neutron, it is called a band rule. It has 11 electron, 11 electron, 11 proton. Now to find out the neutron, that is something you need to work out yourself. You will take the big number, which is atomic mass, minus the atomic number. That will predict the number of neutrons of an element. So you need to understand this equation. I'm going to do one more. For example, magnesium has got 12 and 24. You write down PEN, you have 12, because 12 represents number of electrons or number of protons. so they both are equal. And to find out neutrons, 24 minus 12, which is 12. Here's the point. Why do you think that number of electrons and protons are equal? Because protons carry positive charge, neutrons carry negative charge. Every stable atom, or all the atoms you have when they are in their atomic state, they always have equal number of electrons or protons. So because the protons are inside the nucleus like this, so protons are in the nucleus, electrons are outside. So if you have 12 electrons there, outside 12 there, and they will have some sort of equal balance of the negative and positive charges, and that makes it a stable atom. Now we're going to look at the energy shells in a minute, so do not get confused about that. One more thing, when we talk about an atom atomic structure, proton and neutrons are in the middle and the electrons are in there. And I have said atomic mass means number of proton and number of neutrons. So this part will determine the mass of an atom. But what about the third particle, the third subatomic particles? These three particles are also called subatomic particles, so do not get confused in exam. Subatomic particle, electron. Why haven't they included electrons in the total mass? Because of the one reason, electron has a very negligible mass. Okay, so that's why in the total mass we do not include it, which is something we don't do when we do the atomic mass. Now we're going to look at how we're going to fill all of these. So I'm just going to remove this bit only, and I'm going to go back onto the electronic structure. So you do know that a proton and neutron, they are inside the nucleus. Electrons are present in the energy shells. So that means electrons are constantly moving. Electrons are negative and protons are positive. Now when you look at this, obviously, as a rule to fill the electrons, for example, if sodium has 11 and 23, that's the number we're going to use, because that represents the total number of electrons. What you're going to do, you're going to use the rule 2, 8, 8. That's the rule for GCSE you're going to use. If that's the rule, and I want to put the electrons in the energy shells, that's going to be 2. Then you're going to put 8. So out of 11, you put 2 in the first one. Then you put 8 in the second one, which you can put as a maximum. Then you got 1 left out of 11. So 1 will go in the last shell. Yes, it can have 8 electrons, but at the moment it's going to hold only 1 electron, because that's the maximum it can have. For example, if you do magnesium, before I go ahead, can I write this one down as 2, 8 and 1. Magnesium, on the other hand, you can see that 12 and 24. When you look at it, in the first shell you have 2, in the second shell you have 8, and in the third shell you can have only 2. So because 2, 8, 10 plus 2, 12, so that will show how you fill that in. The electronic configuration is 2, 8, 2. Okay, so that's how you complete the shells based on the rule. One thing I would like to mention in periodic table, you have in the periodic table you also have those sort of compounds, what you call it as where you will use the group number to find out how many electrons are there. If you look at periodic table, if I remove it from there, if you look at periodic table, sodium belongs to the first group and magnesium belongs to the second group. Now if I look at the structure, you will see this last shell is called outer shell, or it is also called valence shell. If you see that sodium has 1 electron in the outer shell, magnesium has 2 electrons in the outer shell. So the last shell has got 1 electron and 2 electrons. If you go back to periodic table, sodium in the group 1 and magnesium in the group 2. So the group number also tells you how many electrons are there in the outer shell. We might will use that in the ionic compound, but you do need to know that there is some information you can have. If you forget about 2A2 rule, you can go back to periodic table. You can predict from there how many electrons are there in the outer shell. In the group 3, they have 3 electrons outer shell, 4, and then 5 electrons in the outer shell. Now, when we look at this, we're not gonna go into details, but please wait for my next video about the structure and bonding. Thank you very much.